Consider the following family of curves: x squared minus 4y squared equals c. If we want to find orthogonal trajectories, which is a family of curves that intersect these curves at right angles, how do we proceed? And the first thing is to make sure the expression is in a form such as this, with a constant only on the right hand side and any variables x and y on the left hand side. Then, once we have it in this form, we need to differentiate term by term with respect to x. So the derivative of x squared with respect to x is 2x. The derivative of negative 4y squared with respect to x is going to be the derivative of negative 4y squared with respect to y, which is negative 8y, times the derivative of y with respect to x. In other words, that's going to give minus 8y dy dx, and the derivative of a constant is just 0. The next step is we then need to rearrange this to make dy dx the subject. So we can subtract 2x from both sides, which will leave us with negative 8y dy dx is equal to negative 2x. And then dividing both sides by negative 8y is going to give us dy dx is equal to negative 2x divided by negative 8y, which we can cancel down by dividing through by negative 2 on the right hand side to get dy dx is equal to x divided by 4y. And this expression here represents the gradient of the original family of curves at a given point xy. Now, when you have curves or lines that are orthogonal or perpendicular to each other, the product of their gradients will be negative 1. So therefore dy dx was x divided by 4y for the original curves, but for the orthogonal curves we then get that their gradient dy dx will be negative 1 divided by x on 4y. And working that out, that is going to work out that for the orthogonal curves, dy dx is equal to negative 4y divided by x, which you'll notice is the opposite sign to dy dx for the original curves and is also the reciprocal. And the final step to actually use this to find the equation of the orthogonal curves is we actually need to solve this differential equation for y. And so, looking at this differential equation, this is first order because that's a first order derivative, and we can see it's separable because we can rewrite this in this case as 1 divided by y, dy dx, if we divide both sides by y, equal to negative 4 divided by x. And from here we can then integrate both sides with respect to x. So integrating this side with respect to x, and also this side with respect to x. And remember that when we get an expression like this, dy dx, that's just going to give us the integral of 1 over y dy. And on the right hand side we had the integral of negative 4 divided by x with respect to x. So working these out, that's going to give us ln modulus of y. So this is equal to negative 4 times the natural log of modulus x plus c. We need to make y the subject of this equation. So we can raise both sides as powers of e, which gives e to the ln modulus of y equals e to the negative 4 ln modulus x plus c. Because e and ln are inverses, that will just become modulus of y. And in this case, though, we need to do a bit of simplification before we can do that. Using our log laws, negative 4 ln modulus of x is the same as ln modulus of x to the negative 4. And we can also break off the constant part of that there by saying that that is of the form e to the ln modulus of x to the negative 4 multiplied by e to the power of c. Furthermore, from there Now e to the power of c is just a positive constant, so therefore this can be rewritten as a constant a, let's say, and this bit e to the ln, again that will just become modulus of x to the negative 4, and x to an even power is always positive anyway, so we can remove the modulus sign there, and as I said, replace e to the c by a constant such as a. And the final thing we can do here, to remove the absolute value or modulus sign on the y, this is forcing y to be positive, and we saw that a is a positive constant, so we can let the solution be bx to the negative 4, where b is equal to plus or minus a, and that will then be our family of orthogonal curves. So that is the general process for calculating orthogonal curves.
Remercie l'éternel Dieu pour ma famille, pour ma famille. Oh, yeah. Dans ma famille, ma famille, ma famille, ma famille. Oh, yeah. Dans ma famille, ma famille, ma famille, ma famille. Ces personnes qui m'éclairent, mon père, ma mère, mes soeurs et mes frères, présent, futur comme hier, ils ne veulent pas que je foute ma vie en l'air. C'est carrément ils gèrent, grâce à eux je vois plus clair. Mes mauvaises manières je les enterre. C'est dur mais ça va le faire, c'est dur mais ça va le faire, c'est dur mais ça va le faire. Yes. Oh, na, 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 yes. Oh, yeah. Dans ma famille, ma famille, ma family, my family. Yeah. Oh, na, 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 yes. Oh, yeah. Dans ma family, my family, my family, my family. Yeah. J'aime la vie, j'aime la vie, yeah. J'aime la vie dans ma famille. Yeah. J'aime la vie. J'aime la vie dans ma famille. J'attends pas le déluge, mes parents, ma police, ce sont mes lois, ma justice. Avec des blés, mais toujours la mystique, la mystique. Quand je suis leur fils et fier d'être un artiste. Dans ma famille, yes. Dans ma famille, dans ma famille, dans ma famille, yes. Oh, na, 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 yeah. Oh, yeah. Dans ma famille, ma famille, ma famille, ma famille. Oh, na, 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 yeah. la vie dans ma famille. J'aime la vie, j'aime la vie, la vie dans ma famille.